Hello guys, today we're going to solve a problem using the current divider method. The current divider method can only be used if all the resistors shown in the problem is parallel to each other. We're asked to find the power dissipated over the 1.2 kilo ohms resistor, the resistor right here. Let's label our resistors, R1, R2, R3. In order to use the current divider method, we need to first analyze the equation for current divider. The current divider equation is IN equals to RN divided by the sum of all the parallel resistors together. And then that is multiplied by the current, the total current of the circuit. R1 equals to 800 ohms. R2 equals to 2.4 kilo ohms. And then R3 equals to 1.2 kilo ohms. If we look at R1, we notice that it's in different units to the other resistors. We have to convert it back to kilo ohms, or we have to convert R2 and R3 to ohms. I'm going to convert 800 ohms to kilo ohms. So R1 equals 800 ohms times kilo ohms divided by 1000 ohms. That's the conversion factor. Then we will get 0.8 kilo ohms as the equivalent. Now let's plug into the equation. So we're interested in I 1.2 kilo ohms, and then we know that Rn is 1.2 kilo ohms. We need to find 1 over R, the sum of all the parallel resistors. And we know the current that runs through the entire circuit, which is 320 milliamps. So 320 milliamps. We can add 1 over R1 plus 1 over R2 plus 1 over R3. We have to take the reciprocal. This equals 1 over 0.8 plus 1 over 2.4 plus 1 over 1.2, and then the reciprocal. If we take the sum of the reciprocal, we get 2.5 kilo ohms as the sum of all the parallel resistors together. Now we can plug this back into our equation here. So we know that I 1.2 kilo ohms is equivalent to 1.2 kilo ohms divided by 2.5 kilo ohms, and then that is multiplied by 320 milliamps. If we plug that into our calculator, I get a value of 106.6 on repeat. I'm going to round that to 106.67, and don't forget our unit milliamps because the kilo ohms cancel out the kilo ohms. Now, we can use the equation P equals to I squared times R to find the power dissipated over R, or 1.2 kilo ohms resistor. So the power that runs to the 1.2 kilo ohms resistor is equal to its current, which we just found is 106.67 milliamps, multiply by itself, and then multiply by its resistance. But in order to use this formula, we have to convert everything into amps and ohms. So 106.67 milliamps is going to be 106.67 divided by 1000 square multiplied by 1.2 times 1000, because Kilo means 1,000. Milli means 1/1,000. And then the power dissipated over the 1.2 kiloohms resistor is equal to, let me plug that into my calculator. I got a value of 13.65, and that is going to be in watts. So here we found the answer. The power that dissipates over R3 is 13.65 watts. The current that dissipates over the resistor is going to be, let's see, 106.67 milliamps, equivalent to 0.10667 amps. This problem, or any current divider problems, can be solved by simplifying a circuit, one with multiple resistors, into two resistors. So we can combine these two resistors into R1, and this will become our R2. The simplified resistor will be, let me draw it out. The simplified resistor will be the combination of 0.8 kiloohms plus 2.4 kiloohms, -1. Because it's in parallel, that's why we take the reciprocal. And then that will be equal to 5/3 to -1, which equals to 3/5. And that's just 0.6. So R1 becomes 0.6 kiloohms. And then R2 stays the same, 1.2 kiloohms, to R2. There is a simplified equation we can use to solve this problem. The equation is IN equals to the total current of the circuit multiplied by the resistor, or the resistant that we don't care, divided by the sum of R1 plus R2. They don't need to be added by parallel. So in our case, it will be just 0.6 plus 1.2. IN, or I 1.2 kiloohms, will equal to the total current that goes into the circuit, which is 320 milliamps, multiplied by the resistor that we don't care. So that's going to be R1, which equals to 0.6 kiloohms. And that will be divided by the sum of R1 plus R2. So 1.8. If we add these up, it's 1.8. This will give us the same answer, 106.67 milliamps. And then we can convert that into 0.10667 amps. And then we just plug it back into the P equals to I squared times R formula, and we will get the same answer. If you're wondering why we can use this equation for a two resistor in parallel problem, it's derived from the general formula that we used before, where IN equals to Rn divided by the sum of the parallel resistors multiplied by I total. Same formula that we used before. I will make a video in the future to go over why this works.